I'm Arn from the Maagdenberg. I'm working on genetics, on different diseases, all have to do with the brain. One of my topics that I'm very passionate about is alternating hemiplegia of childhood. So I do this in Leiden, University Leiden, where I am professor of neurogenetics. So I've been to these meetings quite often, and I'm always very stimulated by the discussions that are going on between the clinicians and the basic scientists, but also the patients and the organizations. So one thing I focus on is finding genes for AHC. We're fortunate to find the first one that explains a lot of the cases with AHC. That's the pump gene, the ATP1A3 gene. And for my background, I have been working on another pump gene, ATP1A2, which is a neighbor, or a sister, if you may say. And that causes a totally different disorder than alternating hemiplegia of childhood. It causes hemiplegic migraine. So you may worry or wonder actually, why do some patients have a mutation in a similar protein, a pump gene, and a pump protein, and why do you have migraine, or whether they have alternating hemiplegia of childhood? So that fascinates me. One thing that is becoming clear is that the ATP1A2 protein is expressed in glia cells, the cells that are also in the brain but have a specific function. They take up neurotransmitter from neurons and terminate neuronal action. Whereas the ATP1A3 gene is expressed in neurons, and they talk to each other. Neurons and glia cells talk to each other through pump genes. And it is interesting to see how a different pump and a different mutation cause these diverse phenotypes. We have been discussing earlier that there may be an overlap between phenotypes between hemiplegic migraine and alternating hemiplegia of childhood. And the hemiplegia comes forward in the first place. But we have not solved the puzzle at the moment. It's way too complicated at the moment to know exactly why a person with a certain mutation has hemiplegic migraine and another one has AHC. There was a question what ATP is actually. We're talking about a pump, and a pump needs energy. Otherwise, a pump cannot function. So a pump is sitting at the cellular membrane and doing its work, transporting sodium and potassium ions. And for that, it needs to have energy. And ATP is the source of energy in the body. So it converts ATP, takes ATP, and then modifies it, and the energy that's released, that's used for the pump to transport these ions over the membrane. So that is the function of an ATP molecule. Not everybody with AHC has a mutation in the ATP1A3 gene. So the question is, what are the other genes? And if you would find the other genes, would that tell you anything about the pathophysiology? Would that help finding a drug for patients? We've done this for a few years together with researchers at Columbia University, Aaron Heinzen, for instance, and David Goldstein. And what we find is something peculiar. We find different mutations that seem to cause disease, but there's not a single gene popping up that would be linked or would be what one would call the AHC2 gene. What seems to be the problem is that the clinical features in these patients that do not have an ATP1A3 mutation are all different. They seem to have more severe phenotypes with a lot of epilepsy in there, and we have to sort out whether these mutations are actually AHC patients causing AHC, or some phenotypes that have some features in common with AHC. That will be a project for the next few years. So being in this conference, it's very stimulating. You see researchers talking very passionate about their topic of research. What we may want to do, though, is try to connect the pieces of the puzzle. We have experts on the pump, experts on genetics, experts on mouse studies, but what we really would need is people that connect the dots, because I think that would be a major way forward. So maybe we should try to communicate in a slightly different way than we are used to, because then we can reach out to each other and help each other with their problem. If you have a solution with your pump, you may want to talk to a clinician and say, does this information fit directly the clinical features? That's far from easy, but I think that this is something that we should do in the coming years, trying to understand each other better, speak each other language, and then trying to build together this puzzle, and that is the solution for HC, finding a new drug for these patients.